Video I'm going to be doing grade 9 ASP end of year focused IPQs. It's quite a lot, so I will break this up. I'm going to start with the equations of motion questions, term 1. Before we go on, there are 3 important equations of motion that we will need to use throughout this exam and these practice questions. The first one is V final equals V initial plus AT. The second one is V final squared equals V initial squared plus 2AX. And the third one that will be important is X equals VI multiplied by T plus a half AT squared. So this top one is great if I don't have a distance. This one is great if I don't have the time. And this one is great if I don't have the final speed. So each of these can be useful. I only need 3 pieces of information to solve anything. Out of all these equations, I need 3 pieces. VI, VF, AT, and X. I need 3 pieces. If I can do that, I can find any of the other ones. Okay, so let's get started. A boy accelerates on a skateboard. If he accelerates from rest at this rate, what is his speed after 3.2 seconds? So VF equals VI equals A equals T equals X equals. I have 1.2 meters per second squared. That's acceleration, 1.2. What is the speed after? That's a time. Seconds, that's a time. So that is 3. Nope, not there. That's wrong. 3.2 seconds. From rest. He started from rest. Starting speed was 0. I want the final speed. So looking at the 3 equations, I've got to VF, VI, A, and T. VF, VI, A, and T. I can directly use the first formula. So that's what we will do right now. VF equals VI plus AT. And that will just simply continue on. VF equals 0 plus 1.2 times 3.2. And if you were to put that into your calculator, you will get 3.84. The correct answer is 3.84 C. A car is traveling at 20 meters per second when the driver sees a ball rolling into the street. From the time he applies the brakes, it takes this much time to come to a stop. So let's see what we can do. Find the average acceleration. So again, we have time, we have speed, and we have, so it's going to be the same formula, to be honest, that one there. You can rearrange it to find acceleration if you like, to A is V final minus V initial over time, but I can keep it like this, VF equals VI plus AT, and I can go ahead and do shift solve to get the answer. V final is the last speed, which it says he comes to a stop. So the last speed he does is a coming to a stop. If you would like to, V initial, you can write it again, A, T, and X equals. V final, he stopped. He was originally traveling at 20 meters per second, so the starting speed was 20. And then, of course, it takes him 2 seconds to stop, and I'm trying to find the acceleration. So yes, VF, VI, A, and T. Same formula. So stopping, I can do shift solve equals VI 20 plus A, multiply that by time, 2 seconds. If you do this, A, you should get, hopefully, minus 10 meters per second, which makes sense because it's negative. He will be slowing down. So very nice. And what's happening here? A car travels on a straight highway with a starting speed, final speed. So it's the acceleration again. VF equals VI plus AT. So we've labeled them out twice now, so I'll go ahead and put the numbers in. Initial speed is VI, so VI is fine. Do we have a final speed? Yes, we have a final speed of 22, VF. That's my VI. Plus A I need. Multiply that by the time, multiply by, what is the time? 8 seconds. A, if you were to go ahead and solve that out, you will hopefully get 2 meters per second squared. Very good. Acceleration is meters per second squared. Speed is meters per second. Don't forget your units. Units are very important. They're worth marks. The graph below shows this relationship between velocity and time. The shaded area under the graph, the area under a velocity time graph, is the distance. Distance equals speed multiplied by time, which happens to be length times width. Of course, it's a triangle, so you will do a half times the length times the width. Long story short, the shaded area is always the distance, or we can say displacement, because it's a vector. So speed time graph distance, velocity time graph displacement. Very nice. Another thing to note, if you do have a graph, and maybe it'll ask you, what is the slope of the graph? Rise over run. That would be acceleration, if it asked. Now, this is all going to be about the same topic, it seems. So what do we have here? A shaded area. We're going to have to figure it out. Displacement during the time. He has a steady positive acceleration. Well, it's a good thing I mentioned that, because we have starting from 0 going up to 5. Then it's a constant speed at 5, and then it slows back down to 0. Steady positive is when you're speeding up. So actually, this is the only part of the graph that I will need. This part here. This is the steady positive. So I will find the area of this. So I will do the distance, or the area, equals a half times the base times the height. A half times the speed times the time. A half times 5. 1, 2, 5. Multiply that by 5. Half times 5 times 5. If you're a wizard with your maths, you'll realize that will simply be 12 and a half. And there's another velocity. What is the displacement from t0 to t4? t0 to t4 leaves me here, and this from 0 to 4, well, that's just a square. That is literally velocity times time, which is what the formula is supposed to be. You can write length times width if you know the equation for the area of a square. I'll just say v times t, just to keep it simple. Doesn't matter, you're just multiplying the two sides, that's all. 40 times 4. 40 times 4, we can get, is that 40? Yes, so the distance will be 40 times 4. Let's check, 40 times 4, of course, why am I doing that? It's obviously 160, but anyway, I've done it just to verify. Very good. The graph shows the velocity of an object varies with time. What is the displacement of the object after, how much? 4 seconds. So we need to figure out the displacement after 4 seconds. Let's go ahead and get that answer. Let's see what we've got here. We have 4 seconds is here. I have 5. So I have this shape and I have this shape. So we have two shapes right now. So let's figure it out then, shall we? We are going to do a half base times height here. And this is negative. So that'll be important as well. A half base times height. You can maybe guess where this is going, but let's see. The first one is a half times 5 times 2, or 2 times 5. This times this. You will get 5 on this side. However, let's look at this one. A half times the base times height, negative 5 times, this is here, and this is also 2. So in this case, you'll get negative 5. The total displacement is you add these together, but 5 plus negative 5, well, 5 minus 5, that's 0. So that's going to be 0. And that's the displacement, so very nice. And we can now move on to this train. And what is it asking for? A train leaves it and accelerates at this rate. And then we need to figure out, what do we need to figure out? Find the distance in the first 1.5 hours. That's here. 0 to 1.5. And that's 2, that's 1. So we're about here. Well, there's two shapes, right? So there's this one, and then there's this one. So the distance will be the triangle plus my square. These are the two things I will include in my distance. So I'm going to have my triangle. So this will be a half times base times height, if I want to write it out, why not? Plus base times height only. Okay, a half, 1. This is going to be in hours and kilometers per hour. Oh, very nice. Okay, kilometers. Is it hours? Yes, it is. 1 times 20 plus the second one. I'll put a little bracket here because that is for the triangle. Now this one is for the square. We have here, between here to here, that's 0.5. 0.5. Because from 1 to 1.5 is 0.5 times 20. 20 kilometers. I'm using kilometers because I can see that we have kilometers and hours. So we'll stick with kilometers. Very nice. A train leaves the station, so now we need to see what the final speed is. What information do we have? Is it the same formula as before? No, this time we have a distance. Vf equals, Vi equals, A equals, T equals, and X equals. I like to do this so I know. This is my distance, that is my X, 800. Final speed, that's what I need, okay. Starts from rest, that's important. Starting speed is 0. Acceleration, we have it, 1.6. Vf, Vi, A, and X. If you were to go to the formulas, Vf, Vi, A, and X. Vf, Vi, A, and X. We will use the second formula. Go ahead, let's do it. Where are we? I've lost it now. I'm not going to do this every time. This is just an example of how you will continue with these questions. So we're going to do Vf squared equals Vi squared plus 2ax. Vf, well, I need it, right? So that could be x in your calculator, you know, when you're doing the shift solve. Vi is 0 plus 2 times a, 1.6 times x, 800. Vf equals, let's go ahead and put that in, and the answer should be 50 final speed should be about 50.6. 50.6, that leads me to right here, 50.6, very good. So Miriam's driving at a speed of 20, she applies a brake close to the signal and travels this distance. So let's see what that will end up being. Acceleration is what we are currently looking for, so let's find it. Vf equals Vi equals A equals T equals and X equals. Miriam driving at this speed, 20 meters per second. She has a speed of 20 meters per second. She applies a brake and travels 200 meters. Before stopping, Vf would be 0, and we don't have a time, but we need to find acceleration. X, Vi, Vf. Okay, so which rule? Vi, Vf, A, and X. Well, that's the same formula that we just did here. So that means 0 equals Vi 20 squared plus 2 times, well, A times 200. Okay, let's try that with a shift solve. 0 alpha equals 20 squared plus 2 times alpha x, that is the A that I'm looking for, times that by 200, shift solve 0, and I will get -1. So that will be -1. The answer I need is here. A trolley at rest is pushed at a uniform rate, and we have to find the velocity after it has traveled. Okay, so Vf equals, Vi equals, A equals, T equals, and X equals. Uniform rate, that should be a squared. There must have been an error there. So 0.5 meters per second squared, so that is acceleration, 0.5, because it did say accelerates at that rate, so that's how I know. What is the velocity after it has traveled? I need this. Starting from rest is 0. Distance is 4. Same formula. Surprise, surprise. Okay, let's do it. Vf squared equals Vi squared plus 2ax. And we, of course, don't know this one, so that'll be my x in my calculator. So Vf squared equals 0 plus 2 times 0.5 times x. That's a terrible x. And times 4. Okay, oh, running out of space on the edge. There we go, times 4. So Vf equals 2 meters per second. 2 meters per second. And that will be here. I think the answer key's got a lot of errors with it because it's not 0.3, although it was 2. So we're going to have to double check the answer keys to see what's wrong with them. Because, yeah, they are not adding up to be the same thing. And let's go ahead. A car begins to accelerate at this constant rate and reaches the speed of this. What is the car's initial speed? Okay, so the car is accelerating at this constant rate and we reach a final speed. We need to find this. So let's go ahead and solve this one out. I've noticed we have kilometers here, but we have meters per second. So I cannot keep km. This must be converted into meters. Vf equals Vi equals A equals T equals X equals 1.6 kilometers. You just simply times it by 1,000, by the way. And that's kilo means times 10 to the power of 3 or multiply by 1,000. So that just becomes 1,600 meters. Acceleration was 1. Final speed we have is 60. And we have the distance, we already know that. And we need to find the starting speed. Vf squared equals Vi squared plus 2ax. 60 squared equals, well, that's what I need, right? Vi squared plus 2 times A, which we've said is 1, times x, 1600. Vi, we're going to go ahead and find right now. Let's go and figure that out. So let's do the shift solve method again, just for fun. 60 squared alpha equals, Vi is what I need, so I'll call that alpha x. square it, so I must do squared, plus 2 times 1 times 1600, shift solve 0 equals, and because there's a square in this, it's going to take a little bit longer for the calculator, and it comes back with an answer, and the answer was 20. Very good. So we will write 20. Where is the option for 20? A is the answer for 20. Very good. Okay. And one more question before I move over. Free fall is the next topic, so I'll finish off with this one. A motorcycle initially moving with this speed, speeds up at this rate, over that distance. What is acceleration? So it looks like it's the same formula again, isn't it? Starting with the initial speed, so I'm just going to go ahead and write Vf squared Vi squared plus 2ax. And I'm going to write Vf, which is the final speed, which we know is 6 squared, equals the starting speed, 4 squared plus 2 times the a, which is what I need, multiplied by the distance of 5. So putting that into my calculator, a equals, let's check. Let's do the shift solve again. 6 squared alpha equals, what do we have? 4 squared plus 2 times alpha x multiplied by 5, shift solve 0, and I get 2 meters per second squared. 2 meters per second squared. And I'll stop that video for now. Thank you.